important. Now, what is this network management all about? The summary of this is you are going to be working on routers, you are going to be working on switches. You need to know how to manage this equipment. Now, it's not enough to just know how to configure a router or configure your switch. You also need to know how to manage them. Manage in what sense? You need to know how to back up the operating system of your router. If anything should happen to that your router, you need to know how to reinstall the operating system of that your router. It's like you have a computer where you have Windows 11, Windows 10, and so on and so forth. You somehow you know that you can have the operating system as a backup with you, or you can go to a place where they sell computer stuffs to just get the operating system, the licensed operating system, which is readily available. But for your Cisco routers and switches, the operating systems are not available. It's not something you just go to the market and go and buy. So when you get these devices, or if you happen to be working in an organization where they use these devices, you need to sorry, you need to know how to manage this equipment. So the moment the equipment is bought, or you happen to get to a place where they have you are going to be the one to be working on the equipment. One of the first things you need to do is to have a backup of the operating system. So tomorrow when they call you that something has gone wrong with the router or the switch, you can bring in the operating system back. That is one of the things that we're going to talk about under network management. Another thing we're going to talk about under network management, it is not good enough to just configure the router or the switch. You also need to back up the configuration file, not the one that is on the router, externally. So if anything should happen to your router or your switch, you can bring up the configuration file from wherever you have backed it up and bring it into your device, and everything will be up and running. So you are not going to start configuring the devices from beginning to the end. No, you already have a backup of your configuration. So all of these things will it will simplify your life, your work, because you know that. So somebody says something, I don't know if it's applicable, but let me just say, he said, blessed are the pessimistic because he has made provision for backup. So you are not afraid that your router will crash, or your switch will crash, or the configuration file will disappear. You know how to you have a backup of these things, and you can always bring them from wherever they are. So we're going to do that also. What other thing can we do as far as network management is concerned? We have some other things to talk about, like how do you see the log on your router, the logs on the router, to know what is going on the router, and so on and so forth. I think another one that is important is somebody sent me a message last week that he was working on a router on Packet Trader and he forgot his password. Is there no way to enter this router without that password? As in more or less like reset your password. I said he should pray, then we make it like a laughing stop. Then I now reply and I say I will be covering that this week. So that's one of the things we are going to talk about in this particular chapter. So network management is very important. You need to know how to manage your devices on the network. So let's see the course objective here. So we're going to be talking about a protocol called Cisco Discovery Protocol. We're going to be talking about Cisco Discovery Protocol. What is Cisco Discovery Protocol? We can use this to map a network topology. If you give me, that is another problem sometimes for your network anyway. If you give me access to one of the devices on your network, I can draw the map of your network, as long as whether you are using Cisco routers or Cisco switches or other vendors, I will be able to draw the map of your network. So we will talk about CDP, we will talk about LLDP. LLDP is also used to map a network topology. This one can be used on, it's open source, but this one is Cisco proprietary. So if I'm working on Cisco devices, I can use CDP. But the moment you have to work on other devices that are non-Cisco devices, you got to use LLDP. Sorry, my pen is misbehaving again. Yeah, I've started the recording. Thank you, Mark. Mark, I appreciate what you are doing in this class. I need to tell you that. Yeah. And please, after the class, remind me, I want to talk about something which is meant for you people's consumption. You can go and think about it. Okay, let's hope we have full house today. So I'm going to talk about LLDP. I'm going to talk about NTP. So maybe that's where I'm going to stop today. We are going to talk about LLDP. We're going to talk about CDP. We're going to talk about NTP. If we still have time, we'll move to SNMP. We'll move to syslog. We'll move to router and switch file maintenance. And then we'll talk about IOS management. So we have a lot to do. And I don't want to rush this particular chapter. I want to do justice to this chapter. Okay? So let's move on. So what is CDP? CDP simply means Cisco Discovery Protocol. So we're going to be talking about how we can discover devices with CDP. Cisco Discovery Protocol. So what is this protocol all about? CDP is a Cisco proprietary layer 2 protocol. Take note of this, please. CDP is a Cisco proprietary layer 2 protocols. Take note of that because I'm going to mention something later. That is used to gather information about Cisco devices which share the same data link. That is connection between the two of them. CDP is a media and protocol independent. It doesn't matter the protocol, it doesn't matter the media, it works and run on all Cisco devices, such as routers, such as switches, such as access servers. So how does this protocol operate? The device, that is the device that is running this protocol, sends periodic CDP advertisement to connected devices. That's how they discover themselves. These advertisements share information about the type of device that is discovered, the name of the device, and the number and type of interfaces. So it therefore means we can get all this information by just activating CDP. So if CDP is running on this router and this router is connected to this switch, from this router I can get the details of this switch. From this switch I can get the details of this router. So I don't need to have a direct connection to this switch to get the details about this switch. From this router I can find out who is this person here. And in case I have another router connected somewhere, from this router here, I can find information about this router that is here. So as long as you are my neighbor, I can find information about you. What if you have another neighbor on the other side? All I need to do is to telnet or SSH into this router here. And from this one here, I can see who is beside this particular router. And that is why they are telling you, or they said, with CDP, you can draw the map of the topology of the network. You can have a network topology. Sorry. Okay. So, what do we need to do in this place? We need to learn how to configure CDP and verify CDP. For Cisco devices, CDP is enabled by default, and I'm going to show you right now. To verify the status of CDP and display information about CDP, enter show CDP command. So if I just enter my router or my switch right now and say show CDP, we are going to see that this particular protocol is activated by default. So to disable CDP on a specific interface, enter no CDP enable. Why do we want to do that? I am also going to talk about that because sometimes this can create security risk for you. So you may have to disable CDP on a particular interface. Okay, so CDP is still enabled on the device. However, no more CDP advertisement will be sent out that interface. So if you are able to deactivate CDP on a particular interface, nothing is coming out of that interface again as far as CDP is concerned. So I cannot see the next neighbor, and nobody can go to the other device and try to find information about me through that interface. So to enable CDP on the specific interface again, you say CDP enable. I'm going to demonstrate all of this. Now, to enable CDP globally for all the supported interfaces on the device, enter CDP run in the global configuration mode. CDP can be disabled for all the interfaces on the device with no CDP run command in the global configuration mode. You can also use the show CDP interface command to display the interfaces that are CDP enabled on a device. The status of each interface is also displayed. So how do we see our neighbor? If you want to see neighbor, so we're going to check this out. With CDP enabled on the network, the show CDP neighbors command can be used to determine the network layout. The output shows there is another Cisco device. You can look at what they did here. We're going to do our own, called S1. Is connected to this interface, your interface on R1, and furthermore, S1 is connected through its fast Ethernet 0/4. What is the meaning of that? Well, on this router 1, we issue show CDP neighbor command. It's telling us that it's a neighbor called S1, and my router is connected to that neighbor on this interface. This is the old time. Old time is how long I can wait before I declare that neighbor dead. High S simply means it's a switch. You can see S here. You can see S in this place. And high means, what is that high? I think it's IGMP. That is multicast. Then we can also see the platform of the switch. That's the model of the switch. And we see the port that the switch is using to connect to us. These are all the details we can get from our neighbor. If we want to get more details, we will not just say show CDP neighbor. We can say show CDP neighbor detail. It will show us that my neighbor is S1. This is his IP address. This is his platform. This is a switch, and it's a 24-port switch. This is the interface that we are using to connect to that particular switch, and this is the that's the switch interface itself. That is the neighbor we are connected to. So this is the local interface on the router here. That is called the outgoing port, and the one on the other side, it is fast Ethernet 0/5. So let's check this out before I give room for question, before we go to another one called LNDP. So I want to share my packet tracer now. So I'm going to bring out two routers. The same thing applies to a router and a switch. Do I use a switch? Let me use routers first. So I'm going to bring out two routers, connect the two routers together. Can we see my router? Hello, can we see my router? Can we see my packet tracer?
Yes, sir, we can see it, sir.
Okay.
Yes, we can see, sir.
So let's find out. Now, I have not done any configuration on these routers. Nothing at all. They told us that CDP is active by default. So let's find out. Let me go to my global configuration mode. I say global configuration, just go to the router. And let's name this one conf-t. Let's name this one London. Host London. So now on this particular router. Now, let me see. They say CDP is enabled by default. Show CDP. We can see that it's telling us global CDP information, sending CDP packet every 60 seconds, sending old time value of 180 seconds, and the version of CDP that is sending is CDP version 2 and is enabled. We did not do anything on this router. If you carry a Cisco switch, the same thing. They said this CDP is enabled by default. So what is the job of CDP? It will help us to discover the neighbor. Okay. So what else can we find out here? Let's see other commands that we can issue. Let's check the interface. CDP shows CDP interfaces. So it's telling us that CDP is running on all these interfaces, even though these interfaces are done. Why is it running on these interfaces? Because by default, CDP is running globally on this particular device. That is why we can see that even though those interfaces are not active, CDP is activated on those interfaces. What if we go to one of the interfaces and disable CDP? Let's say interface G0/0 and say no CDP enable. Remember we talked about that command just now. I am trying to disable CDP on that interface because I don't have any other Cisco device connected to that interface. Maybe I don't want anybody to now connect to me and be able to use that interface to draw the topology of my network. So I can say no CDP enable. So I've activated that on that interface. So I can issue that command again. Show CDP interfaces. Which interface? Where did we enable it? On G00, it's still showing me. Let me activate that interface first and see if it will show. Interface G0/0. I'm not going to put any IP address. I will just activate it and say no shots. It's not supposed to show me this. Okay, I am still seeing the output here. Ideally, I'm not supposed to see the output, or I believe I'm not supposed to see the output that is still sending packet on that interface once I've disabled CDP on that particular interface. But I will check out on that one and get back to you people. So, but I want to use it, I want to put it back because I still need that interface for to display other things. CDP. So if I want to enable it back, I see CDP enable, but I will still disable it back and see. Let me see if it's going to see the neighbor. So we have confirmed that CDP is running by default on this router. We didn't configure it. So now let's now configure the other router. So this particular router, let's just give it an IP address. They are both connected on G0/0. IP address, let's say 200.100.100.1 subnet mask. So I'm giving this particular interface 200.100.100.1. So let's go give the other interface 200.100.100.2. Let's say this is Germany. Now don't forget, I said when you build, test for connectivity. Let's see if this guy can see the other side. Good. So London can ping, Germany can ping London. So now let's assume I only have access to London router. And for some reason, I don't know who is my neighbor. So I can say show CDP neighbor. So if CDP is running on that interface, that is the G0/0 where they are both connected. You can see I'm using my pen. Sorry, just a minute, please.
Take.
So let's assume, okay, let's assume we now disable CDP on this interface. It's not supposed to be able to see that neighbor again. But let's find out for ourselves. Okay. So I can go to this router. I'm on that router now. I've issued this command, show CDP neighbor. So let's see if you can see its neighbor. So it's telling me that you can see a neighbor and the device ID is Germany. That's what's on the other side. This is my local interface. And the person that is my neighbor, the old time, that is when next, if I don't hear from that guy for 51 seconds, I'll declare the guy dead. Capability, the guy is a router. And this is the model of the router. And this is the interface of the router. I should have used a different interface on that side for you people to see so that we'll see the difference. Let me just do that right away. So I have put my connection on a different interface. So let me configure that interface fast. Oh, is this overlapping? Let me shut down the other interface. Sorry. Interface G0/0. No IP address. Then let me continue. So I will remove the IP address. And say no shot. So now, let's see if we can reach London. Good. So now go back to that router. That is the London router. And see if you can see our neighbor. So I'll issue the same command, show CDP neighbor. You can see now, my neighbor is Germany. This is my interface that I'm using to connect to my neighbor. This is, why is it showing me two? It's supposed to be just one. I think the table needs to be clear. That's the old one that we had here before. Is there a way to clear? I don't know. Let me find out. So this is the whole time. It's a router. This is a capability. I am connected to that particular router on this interface. But we can go beyond that and say show CDP neighbor details. If I hit enter, it will not just show me that my neighbor is router, or if you give me the IP address of my neighbor. You see, my neighbor is Germany. If I have more than one neighbor, it will show me on right, on the left. This is his IP address. Platform 62900. That's the model of the router. It's a router. This is the interface I am using to connect to that neighbor. And that is my outgoing port. And that's the where I'm connected to the guy on 0/1. So with this, beyond that, I can see the operating system that device is running, the operating system of that device. So if I am on the network, the moment I have access to one of the devices, I can begin to issue this show CDP neighbor command. I can now begin to draw, okay, from me, I'm a router. There's another guy by my right. He's also a router. His IP address is 200.100.100.2. This is its interface. This is my interface. If there's another neighbor on the left, you can also draw. There's another one on my left. This is IP address. These are the details. This is the operating system. So if you now need to see more neighbors, you telnet or SSH to the other routers. Those ones that are your neighbor, because you can only see your directly connected neighbor. Beside that, you cannot see neighbor to your neighbor. No, you have to go to that neighbor's house and issue the same command so that you can begin to you can continue drawing your topology based on the directly connected neighbors. So CDP enables you to it enables you to draw it gives you visibility about the topology of your network. But CDP is Cisco proprietary. What if you are running LLDP? I mean, yeah, what if we are using other routers that does not belong to Cisco? we have to run LLDP, which is open source. So give room for question before we move to LLDP. Any question? Okay, can we continue? If there's no question, can we continue?
Yes, sir. Continue, sir.
Okay, so now let's go to that interface and disable CDP and see if it is still going to work. So for us to disable CDP on the interface is no CDP enable. So I've disabled the CDP on that interface. Let me see if you can still see my neighbor. So it's one of two things. Like either this is not working on Packet Chaser, or we give it time to time out. But I doubt it. So ideally, once I disable CDP on that interface, I am not supposed to be able to see my neighbor again, because that is the interface. Let me see if there's anything like clear CDP. Okay, clear CDP what? Table, yeah. Good. So let's issue it and see again. Yeah, this is what I think. This is what I needed to do. So it's not giving me my neighbor again. So it was just showing me. Now look at it now. No neighbor. Show CDP neighbor. It's not seeing anybody. Why? We disable CDP on that interface. So sometimes you want to disable CDP on your router. Now that does not mean it's disabled globally, because if I say show CDP run, you see that it's still running. Show CDP words. I think it shows CDP. Okay, just show CDP. I can see that CDP is still enabled on my router, but I have disabled it on one of the interfaces. So I had to clear the CDP table to get rid of the old information in the table for us to see the new thing. So we can go back and enable it. We can go back to that interface and enable the CDP and say CDP enable, and that will put it back there. And if we now issue that command, say so the CDP neighbor, so CDP neighbor, we should be able to see our neighbor. I think it's a timer. You need to send the advertisement, and after the advertisement, you should see the neighbor. So let's wait for it for us. See, they need to talk between themselves. So let's see. Still not send the neighbor. I've re-enabled it back. Let me check. Let me be sure it's there. Show CDP interfaces. Okay, so my G00 here. Okay. Oh, wow. I think we needed to wait for the advertisement to go. So it's in our neighbor at Germany. And this is all the things I've analyzed for you people before. I can make it details. I see detailed information. So you see, now CDP is now working. So beyond that, we can disable these things globally, because sometimes they tell you they don't want CDP at all on that particular device. So I think it's let me check the command. No CDP run. Okay, scuba configuration mode. No CDP run. Now, because I've done this right now, if I say so CDP, you see that what is telling me here, CDP is not enabled. Why is CDP not enabled? I disabled it. Why will you disable CDP? Because sometimes it can create security risk for you on your network. If you know you don't need it, you know the topology of your network already, you don't need the help of CDP, get rid of CDP on your devices. And that is the end of CDP. So two commands or few commands: CDP neighbor, show CDP neighbor, show CDP neighbor's detail, CDP enable, no CDP enable, CDP run, no CDP run. Few commands to just get to work with Cisco Discovery Protocol. Any question on that? Any question? All right.
Yes, sir.
All right. So I believe it's clear. So what if you are working on another device that is not Cisco device? It's Cisco device. So what do? CDP is not going to work on that device. So you have to use LLDP. LLDP, link local discovery protocol. I believe. Let me check my PowerPoint. Link layer discovery protocol is doing the same thing as your CDP, just that it's not from Cisco. It's vendor neutral, meaning any device, any router, any switch, any access point, as long as it's not Cisco. This is open source. LLDP can work on any of those devices, so you can still take advantage of that. So same thing we have explained. Now that one is not enabled by default on Cisco router. You can see I just issue show LLDP. What if you want to enable the LLDP? All I need to do is just to say, I think it's LLDP, global configuration mode. LLDP, let's see all the options, run. If I now go back and say show LLDP, you see that LLDP is now active. Status is active. It's beginning to send its own advertisement. And this is its own downtime. It is going to do the same thing like your CDP, just that this time around, it's going to be using open source. So let's go and activate that on also on the other side and see what happens. LLDP run. So right now, let's see if we can see, these neighbors can see themselves. So I'm going to say show LLDP neighbor. So the other one we said show CDP neighbor. But now we are using open source. We are going to say show LLDP neighbor. So we are seeing now that our neighbor is Germany. This is our interface. This is the old time. Our neighbor is your router, and this is the interface on our neighbor. We can also go and say show LLDP neighbors. I think it's details. You can see just like Cisco's own, but this one I think it can give you some other information beyond what Cisco's own will give to you. So we can see the interface of our neighbor. That's the interface of our neighbor. It's on G0/1. His name is Germany. Where is his IP address? I'm looking for his IP address. I'm supposed to also have his IP address. I need to check his house, but I don't know if this one doesn't display his IP address, but that one don't make sense to me. I need to check this. Okay. So I need to check this out, please. Let me see. It's only detail option I have here. Okay, I'll check this and get back to you guys on that. So what we have basically in this place is just the opposite of what CDP is doing. In the sense that, as in, not really the opposite, as in the same thing, but the protocol is different. So if you are working on a non-Cisco device or you are working on non-Cisco devices, you know that you go for LLDP. If you are working on Cisco devices, you know that by default CDP is there. But in case you don't need the CDP, you disable it. And of course, LLDP is not active on your device or your devices. So you can explore this. They do the same thing. Just like it depends on the platform you're working on. So, question on that. I don't want to go beyond the basics that I think we should cover here. So, these are just the things we still have in the PowerPoint. So, you can do the same thing. You can see We can decide to say you should transmit alone. You can see this command here. That's my pen again. You can decide to say you are this interface, we want you to just transmit this LLDP message or just to receive LLDP message. We can do that. You can see we can show LLDP to see the LLDP information. We can see our neighbor. I've demonstrated that. Shows the LLDP neighbor. We can also do the details. Okay, in this one too, there is no IP address, but they said it can show us IP address. So am I the one not seeing the IP address? It's just showing us the port ID, the description of the port, the name of the port, the detail of the operating system, and then the platform. I can't see the IP address. Anyway, I will check that and get back to you guys on that, please. I will research that. But because Cisco's own can do that, I believe this one too should be able to do that. Except if that's a problem on Packet Tracer. All right. Any question on that? CDP, LLDP.
Understood, sir. No question.
It's like this class is too simple. I should have left you guys to read it on your own.
No, sir. No, sir. You're doing well, sir.
I'm
Go
doing
ahead.
it, but I'm saying is since people are not asking questions, it means it's too simple. And you should have said, read this chapter and you'll be good. It's very simple. All right, so let's finish. Let's take the last part I would like to talk about this evening before I stop the class. I told you I'm going to talk about just 3 things. Network time protocol, NTP. Why do we need to talk about NTP? It's very important on our network. Now, people don't care about whether you set time on your routers or your switches, but these things are very important. Because if somebody should log in into your router, you want to have an idea of when the person logged in, when the person logged out. You want everything going on in and out of your router to be time stamped. And if the time is not correct, if somebody hacking into your network by 10 a.m. in the morning and you enter your router to see the log and it's showing you that the person came in by 10 p.m., you know that you've been misled already. You cannot make informed decision because of that. That is why time is very important. And so how do you set this time? You can have a server that is going to be the time server that will be dishing out this timing to all the devices on your network. It's more or less like your phone. When you have a phone, the moment there's a place on your phone where you can tell the phone to get information automatically from the service provider, like all this MTN and the rest of them. And you see that the time will be correct on your phone, the date will be correct. The reason why you got that kind of information because they have not a router, a server, a time server it is called, that is running a protocol called NTP, Network Time Protocol. And once your device synchronizes with their own, then you will get the correct time from them. And not just time, you get the date and so on and so forth. So also on our network, our timing must be correct. So we can decide to we make one of our routers a server, a time server, to give time to other devices on the network. So meaning we will set the correct time on that server, on that router, and then tell other devices to come and get their details, time detail from that particular device. But this is very important and it's crucial. So the software clock on a router or switch starts when the system boots. It is the primary source of time for the system. It is important to synchronize the time across. Now look at that now. It is important to synchronize time across all devices on the network. One router shouldn't be saying it's 10 a.m., the other one is saying it's 11 a.m., the other one is saying it's 12 a.m., and so on and so forth. So for you to be able to achieve that, you activate this protocol. When the time is not synchronized between devices, it will be impossible to determine the order of the event and the cause of an event. Typically, the date and the time setting on a router or switch can be set by using one of the two methods. You can manually configure the date and time as shown in this place, or configure that date and time through network time protocol, meaning you will tell that device to go and look for a time server. You point it to a time server, and we're going to see how to do that briefly. As the network grows, it becomes difficult to ensure that all infrastructure devices are operating with synchronized time using the manual method. A better solution is to configure NTP on the network. That is it. We need to activate that, especially on a big network. This allows routers on the network to synchronize their time setting with an NTP server, which provide more consistent time setting. NTP can be set up to synchronize to a private master clock, or it can synchronize to a public available NTP server on the internet. NTP uses UDP port 123 and is documented in RFC 1305. So let's see the configuration. Now this is the way NTP operates. You can have what is called NTP operation, and they have them in different, do I call it hierarchy? That's the best word. Stratum, we have hierarchy. So we have hierarchy. So the journey always starts from stratum 0, meaning the main guy, that is the time, the clock, given to a stratum 1, which is the server. And this server can also give to other set of servers. They become stratum 2. And stratum 2 also can give to another server. That one becomes stratum 3. It simply means I can get information from the internet. Like I can configure my router to obtain this clock from the internet and become the server to other devices in our network. Is a client to the time server on the internet. That is my router now. But that my router will also become a server to other devices on the network locally. So we can implement it either of these ways. Okay. NTP network uses a hierarchical system of time resources. Each level in this hierarchical system is called a stratum. The stratum level is defined as the number of opcounts from the authoritative source. The synchronized, sorry, just a minute. The synchronized time is distributed across the network by using NTP. So this thing you are seeing that is going, sorry. This hierarchy that you see saying that is going from this source to definition like this, you cannot go beyond 15 opcounts, meaning 15 servers. We may have to look for another one that will start the journey all over from 0. That is for your information. So stratum 0 is the authoritative, is the high precision timekeeping devices assumed to be accurate with little or no delay associated with them. And you can have one that is directly connected to the authoritative time sources, and you can have 2 and then lower, 2, 3, and so on and so forth. So let's just see how this thing works. So how do we configure and verify this thing? The first thing we need to do before NTP is configured on the network, the show clock command is display. Show clock command display the current time on the software clock. With the details option, notice that the time source is user's configuration. Now you can see it. Can you please mute yourself? That means the time was manually configured with clock command. We are going to do that right now. So let's do that right now before we come back here. Let's check some things on my packet tracer. The same routers we've been using. So let's check some things. Let's see there is time. Show clock. Look at the time we have here. This router is still in 1993. So you can see that this is not good. Let's see show clock detail. So it's telling you that the time source is where. Where did they get this time from? Hardware calendar from our device. So we can set this time now. The command is clock. I think set, yes. Set. What comes first? Now look at the arrangement. Hour comes before minute, comes before second. So if I say now, the time now is 07. The minute is 50. Let's say the second is 00. What next? The months. This is 909. What next? I'll put month now. Day of the month, sorry. Day of the month, that should be 20. Then, what next? Then, month of the year. Maybe you want me to put it. This is September. Don't know the format here. Let me see. Okay, good. And this is 2022. If I hit enter right now and go back and say show clock, see that our time has changed. We have changed the time of this router. How did we change the time of the router? Who did that? So if I say show clock detail, it's telling me that it is user configuration. Somebody changed this thing manually. So right now, we can go to the other router and tell the other router to get his own time from this particular, from London. Tell Germany to get his own from London. So how are we going to do that? We activate network time protocol. So how do we do that? We'll go to global configuration mode and say NTP master. Yeah, I think NTP master. Then we can give a number. Any number can be there. You can say NTP master 10. Hit enter. Go to Germany router. Before we activate that, let's check this guy's time first. Show clock. You can see this guy too is in 1993. So good. So but we don't want to configure this guy manually. We want this guy, this Germany router, to go and get his time from London. So what do? We point this guy to London. We say NTP not master again now. NTP server, yeah. That server is 200.100.100.1. If we hit enter now, by the time they find this guy is able to discover the other guy, you'll see that it's going to synchronize and our time is going to change. So let's wait for it to come. As all things being equal. Now let me see if we can reach that guy. Okay, good. So I am .2. The other guy is .1. Good. So let's wait for it and see when you get its time. Show clock. It can be slow, but we're going to get there. So while we're waiting, if you have questions, please go ahead and ask. Ifan, you have the floor.
Yes, sir.
Yep.
Is it possible to make the router get clock or the time from the internet instead of setting it manually?
Yes, I said that earlier before I started the lab. We can make the router to get from the internet and then make that router the server for our LAN, time server for our LAN. Do you understand?
Yes, sir.
It's very slow. What is it called? It's slow. And let me see if there's any other command to see what's going on. Show NTP. That's not it. But show NTP status. Yes. This is where it's until we see this thing it's still, you see that it's saying our clock is unsynchronized. Until it synchronizes, we're not going to get correct time. So we need to keep on checking. This is the first time I'm doing this on Packet Tracer. So I'm going to wait. Any other question, please, while we are waiting? Any other command there? Okay, association is there too. It has associated. So why is it not giving it clock yet? Okay, no, it's not yet associated. Okay. Can you see now? It's telling me that clock is synchronized. Now that I have clock is synchronized, I should have the correct time on my router now. So I will now just show clock. You see that now my router has gotten its clock from the London router. So let's assume you have like 10 routers on your network, or a router, 2 routers, 10 or 220 switches, 200 switches. You configure all of them to pick a clock from the main router. Make sure the clock issue is synchronized across board on all your devices. And with that, if there's any issue, you'll be able to pinpoint. This switch is saying it happens so time. The router is saying it happens so you'll be able to know that no, it cannot be beyond that time period. That's when the thing happens. So this is what we need to learn about network time protocol. Any question? Any question?